In 1992, a construction crew in San Diego hit something with a bulldozer. State archaeologists were called. They excavated for 5 months. What they found were mastodon bones, broken in patterns consistent with deliberate fracture, surrounded by stones that showed evidence of use as hammers. Radiocarbon dating wasn't applicable at the relevant depth. Uranium series analysis of the bone carbonate was used instead. The result: 130,700 years old. The lead researcher, Tom Dillehay, spent the next 25 years running additional analysis before publishing. The paper appeared in Nature in 2017. The implication: humans were present in North America 115,000 years earlier than every accepted model allows. The field's response was not acceptance. It was a replication demand that has never been met. That discovery is the third on this list. 2 of the 5 we're looking at today have been formally accepted by archaeology after years of sustained institutional resistance. 2 remain actively contested. The last, Gunung Padang in Indonesia, is the subject of a 2023 peer-reviewed study that has divided the field so sharply that no consensus position currently exists. In every case, the evidence came first. The resistance was institutional. Stay with us, we'll tell you exactly what the 2023 Gunung Padang study found and why the field hasn't resolved it. In 1975, a young American archaeologist named Tom Dillehay began excavating a waterlogged site on the banks of Chinchahuapi Creek in southern Chile. What he found was evidence of human habitation, wooden structural remains, stone tools, plant material, dated to approximately 14,800 years before the present. This was a problem. The dominant model at the time, the Clovis First hypothesis, held that the first Americans crossed the Bering Land Bridge from Siberia and spread southward through an ice-free corridor, arriving no earlier than 13,000 years ago. A settlement in southern Chile at 14,800 years old is geographically and chronologically impossible under Clovis First. To have reached that latitude at that date, Monteverde's inhabitants would have had to be in the Americas at least 2,000 years earlier than the model allowed, and via a coastal route, not the inland corridor. Dillehay published his findings across the 1980s. The North American archaeological establishment's response was sustained rejection. Some critics challenged his dating methodology. Others questioned whether the wooden remains were structural rather than naturally deposited. The Clovis First model had held for 50 years, and Monteverde contradicted it at its foundation. In 1997, a multidisciplinary review team of 9 archaeologists visited the site. Their assessment, published in American Antiquity, was unambiguous. Monteverde was genuine. The dating was valid. The physical record supported cultural identification. Clovis First, as an absolute model, was formally abandoned within the following decade. Dillehay had been correct for 22 years before the field confirmed it. In 1991, Christopher Henshelwood of the University of Bergen began excavating a coastal cave on the southern tip of the African continent. In the deeper stratigraphic levels, layers dating to approximately 75,000 years before the present, he found 2 pieces of ochre engraved with deliberate geometric crosshatch patterns. Abstract symbolic marks applied to a pigment mineral 75,000 years ago. Prior to the Blombos findings, the accepted date for what researchers call behavioral modernity, the cognitive capacity for symbolic thought and abstract representation, was approximately 40,000 to 45,000 years ago, based largely on the European Upper Paleolithic record. The implication was that symbolic cognition had emerged relatively recently, possibly connected to a specific genetic development. Henshelwood published in Science in 2002. The 2011 excavation season added a complete ochre processing kit from a layer dated to 100,000 years ago. Grinding stones, shell containers, bone spatulas, a full toolkit for producing pigment with no immediately functional purpose other than symbolic use. The cognitive capacity for symbolic behavior was not a recent development. It was roughly twice as old as the European record had suggested. The Blombos findings are now accepted across the field. The full implications for what happened between 100,000 and 40,000 years ago, and why the European record looks the way it does, have not been resolved. The 1992 San Diego discovery stayed in storage for 25 years before Tom Dillehay and his team published in Nature. The delay was deliberate. Dillehay knew that a date of 130,700 years was extreme enough that the methodology had to be demonstrably rigorous before the finding could survive peer review. The physical evidence was specific: mastodon long bones bearing percussion marks and spiral fracture patterns consistent with deliberate breakage to extract marrow, found in direct association with 5 large cobblestones showing edge damage and impact points consistent with use as hammers and anvils. The spatial relationship between the bones and the stones was precise. This was not a random scatter of material. The field's response divided along methodological lines. Critics, including a group that published a formal response in Nature, argued that the bone fracture patterns were consistent with non-human processes: geological pressure, seismic activity, trampling. Proponents noted that the combination of specific fracture patterns, marrow extraction evidence, and the precise co-location of bones and cobbles was not consistent with natural processes as documented in the comparative literature. No replication study has been published. The Cerruti mastodon remains the most contested individual site in American archaeology. If the cultural identification is confirmed, human presence in the Americas predates Clovis first, not by 2,000 years as Monteverdi showed, but by 117,000 years. The model would not require revision. It would require replacement. In the Casma Sechin Valley on Peru's Pacific coast, there is a ridge with 13 stone towers running along its crest from north to south, built between 300 and 200 BCE. The site was documented in the 1930s and classified in the archaeological literature as a fortification. That classification held, unchallenged, for 60 years. In 2007, archaeologists Ivan Gezi of the Catholic University of Peru and Clive Ruggles of the University of Leicester published an analysis in Science. Using systematic solar observation from 2 viewing platforms identified at the site, they demonstrated that the 13 towers function as a horizon calendar. Observed from the eastern platform, the sun rises behind successive towers as the year progresses. The entire solar year, solstices, equinoxes, and all points between can be tracked to within 1 to 2 days of precision. This is the oldest confirmed solar observatory in the Americas. It is 2,300 years old. Its precision is comparable to astronomical instruments used in European astronomy 1,000 years later, and it was in the archaeological literature for 6 decades classified as a defensive structure because no one had tested whether it might be something else. The question Chanquillo raises is not specific to this site. How many other documented structures in the formal record are currently misclassified? Not because the evidence is missing, but because no one has yet applied the relevant analytical framework. On Java's Western Plateau in West Java Province, there is a terraced hill called Gunung Padang, the Mountain of Light, that has been a sacred site for centuries. Archaeological interest began in the early 2000s when surface surveys identified structured stone columns. In 2011, a government-funded excavation led by geologist Danny Hillman Natawijaja began systematic subsurface investigation using core drilling and ground-penetrating radar. In October 2023, Natawijaja's team published findings in Archaeological Prospection. Core drilling had identified 4 distinct construction phases extending to a depth of approximately 15 meters below the current surface. The deepest phase returned radiocarbon dates ranging from 25,000 to 14,000 years before the present. If those dates reflect the age of construction, Gunung Padang would predate Göbekli Tepe by at least 14,000 years, making it the oldest known large-scale constructed monument in human history. The international archaeological community's response was immediate and divided. Researcher Flint Dibble of Cardiff University, along with several co-signatories, published a formal critique arguing that the dated organic material, soil inclusions recovered from drill cores, may not be contemporaneous with the construction phases, and that the geophysical evidence for deliberate human construction at the deepest levels is not distinguishable from natural geological layering. Natawijaja's team responded that the regularity of the stone arrangements and the pattern of the subsurface geometry is not consistent with natural deposition. The 2023 paper has not been retracted. A formal independent replication survey has not been published. The dates are real. The drill cores exist. What they represent, whether it is the oldest constructed monument on Earth or a natural geological formation that the team has misinterpreted, remains, as of today, unresolved. What connects these 5 cases is not the magnitude of the revisions they produced, though in each instance the revision was substantial. What connects them is the mechanism of rejection. In each case, the dominant model was treated not as a hypothesis that new evidence put under pressure, but as evidence itself, against the finding. Monteverde contradicted Clovis first, therefore Monteverde was suspect. Blombos contradicted the European Upper Paleolithic timeline, therefore the dating was challenged. Chanquilo was in the literature as a fortress, and no one looked for something else. The two findings that are still contested, Suruti and Gunung Padang, are following the same structural pattern. The evidence is real, the question is what it represents, and the question has not yet produced a consensus. Archaeology doesn't get things wrong permanently, but the timeline of correction, sometimes years, sometimes decades, is a structural feature of how the field processes findings that contradict established models. Which means there is currently material in the formal record that will look, in 20 years, the way Monteverde looked in 1995. The question worth asking is which of the currently contested findings you think is most likely to be accepted within the next decade, and what it would take to resolve it. The Suruti Mastodon needs a replicated excavation of comparable material from the same stratum. Gunung Padang needs an independent geophysical survey. Neither has happened yet. Tell us in the comments which one you're watching, and if you know of a contested discovery that deserves more attention than it's currently getting, make the case below. If today's topic fascinated you, we've compiled 50 of the most unexplained ancient discoveries into one guide. Every site, every mystery, the competing theories, and the sources. Link is in the description. And if this video added something to what you knew, subscribe. We publish a new ancient mystery every week.